Okay, so welcome to the second half of this class, the third class in Emerging Technologies for Lifelong Learning. Before the break, I introduced you to, I guess, the world of Wolfram Mathematica. That's like an ecosystem, so to speak. I give you just a glimpse of the tools, the main tool, which is to do functional plots and plot of molecular data and so forth, and manipulate the view and the parameter using what's called manipulate function, right? So hopefully you got a glimpse of how high level the language is, okay? So for those of you who may or may not know, computer programming is organized into different what's called programming paradigm. Okay, it's not like you can say that different language, different English, Japanese, or Thai have different writing system. Okay, likewise, different programming language have very different stylized way of communication. Okay, these are called programming paradigm. Okay, I just give you a quick word, and this is something you probably should know, regardless of where you are or where you're going to be. Right. So I guess the lowest level of programming is to manipulate the bits. Okay, none of us is operating at that level. Okay. When we go to new technology like quantum computing, that's when we actually will be operating at the bits level. But for silicon, digital computing as we know it, it's called von Neumann architecture. Don't have to memorize that. You don't have to go down to flipping 0 and 1. You always hear this thing about computer is all about 0 and 1, but at the end of the day, you never touch the 0 and 1. Okay, you always operate at the top level. So, what do you mean by computer programming? When you programming computer, you're giving it instruction, but how do you instruct? How do you communicate what you want done? Okay. So there are several paradigms. Okay, one paradigm is called procedural programming. Okay, this is where you actually tell the computer all the steps. This is the sort of programming that my generation probably learned as a first thing, maybe like in C language or something. Okay, do this, do that, go here, go there, loop this 3 times, check this, check that, then this, then that, do this, do that. With this piece of data, create this new variable, change the value, do that, report this, print that. So give it the procedural. Okay. Now, procedural just kind of like a little bit unstructured. It's sort of like giving the whole story, what to do. But later on, maybe not later on, but people start thinking about you should organize this into units, reusable unit. One of the reusable unit is called functional programming. In other words, instead of telling computer what to do, you agree with the computer that there are certain functions that would do certain things. Some of the functions are built in. For example, function to compute the sign, function to plot. So these are built-in functions. But if you want something more tailor-made, you can use the built-in function, couple them up together, and make a user-defined function. So you can think of, let's say, maybe, I don't, the number may be off. Let's say Mathematica by now has 50,000 built-in functions. So it can do 50,000 things already, okay? So this would be the function that starts with a capital letter and followed by small letter. And when you type it, it's in black, okay? Because the computer knows what to do. And if you want to do something more specialized, by putting a whole bunch of functions together, you can wrap it up into a bigger function that you define yourself. This is called user-defined function. So when you want computer to do something, it's a 2-step process. You define the function that embeds the steps, and then you call those functions, right? So if the computer knows how to fry, the computer knows how to beat an egg, right? But the computer doesn't know how to make an omelet. You can define a function called make omelet. And that function uses internally two functions, beat egg, send the result to fry. That makes sense? Okay, so beat egg would be black already because the computer knows what it is. And, fry is also a black function because the computer knows what it is. But make omelet is something you need to do. Okay, this is the way we call functional programming. Okay, now pure functional programming sometimes does this in a way that doesn't have to name things. You kind of like abstractly name the action, but we don't have to go into that. And that's what Python is fundamentally. That's what Mathematica is fundamentally. However, it can also communicate with you in other paradigms as well. But mainly, it's not procedural, it is functional. Okay, so you know now two paradigms. Okay, procedural, tell all the steps. Functional, the small step that does certain thing you do all the time. You don't want to keep saying it again, right? Right? So the step that has to do with frying, that has to do with, turn on the heat, put in the oil. You don't want to keep saying that. So you wrap everything under the function called fry. Then you wrap everything under a function called beat an egg. Now, because you make omelet all the time, you don't want to call those two functions. So you wrap those two together and call make an omelet. Okay, and then whenever you need to make an omelet, you make an omelet. But then, of course, you leave a room. The notion of function y is equal to f of x is that when you use f, you have to supply x. X, the variable in functional programming, is called argument. So in your case, the fry make an omelet can have a parameter called how many eggs? Okay? Or how hard do you want it to be? Right? Or whether or not you add chives and onions or not. Or whether or not you use butter or margarine or oil or pig fat or whatever. Okay? So you define that. You define it with room for specialization through parameterization. I'll show you how all this works, okay? But I'm just going to give you the lay of the land first. So what else? There's another thing called object-oriented. I'm not going to go into that, but that's actually my thing. So C++ language, I use that for my PhD actually. So I'm going to skip all that. So let's go straight to Mathematica as a functional programming. Okay. So now open your Mathematica notebook. Start from scratch again. I'm going to use my notebook. Okay, this notebook is work. Okay. Okay, this would be my, I guess, interactive notebook. I shift enter a whole bunch of things. These are sort of like formatting default kind of thing. It doesn't really mean anything. Okay, you don't need to know that. Again, this chapter, we're not going to, okay, introduction to Wolfram Mathematica. Okay, So briefly, I'm just going to walk through this. And so this kind of history, this kind of Mathematica 1.0, blah, blah, blah. Again, every time you're going to see this is all the text, right? Now you don't have this, so you can type. And all these things that I pre-type, okay, but I haven't recompute, it's going to have this kind of ghostly input output. In fact, let me do this. Evaluate cell, delete all output, because 1 + 1 is equal to 2. This is from previous iteration. Okay, so delete all output, right? Okay, so all output is gone. All you have is a bunch of pre-typed input. Okay, so 1 + 1 shift enter. So you type exactly along the line. Okay, and you can turn this in at the end of the class. I mean, how easy can that be? 1 + 1 is equal to 2. What happened here? 1 semicolon 2, 3 + 4 semicolon 5. What do you think will happen? Well, what happened is different line is different command. But if you put semicolon, it's just going to silence the output. So basically, if I put in, say, something like 1, okay? Okay. Oops, sorry. 1, okay? And I shift enter, it's going to come out 1. But if I put 1 and I put semicolon, it sort of like silence it. So nothing comes out. Okay, number still goes up, 44, 45. Okay, so this likewise doesn't do anything. Okay, gives you 2, gives you 5 because there's no semicolon by it. Blue, okay, type in the word blue, guys. Blue, okay. Now, once you type in the word blue, you notice that you don't get the word blue back. You get a block, right? It turns out that blue is actually a prompt for a function. And if you put your mouse over it, you will see this RGB color. And if you double click on it, that becomes your color palette. Right? That becomes your color palette. In fact, I can do this. In fact, instead of blue, I could go RGB color, red, green, oops, it's from 0 to 1, and blue. What do you think is going to happen? All red, no green, all blue. It's going to give you purple, right? Likewise, if I just have all red, it's just going to give all red, okay? So this is actually an example of a built-in function. That function expects 3 number. You can't give it more, you can't give it less. There's no flexibility here, okay? When you give it less, it doesn't like it, okay? It would just assume, that's not good. Null, I don't know what null is, but I know what 0 is, okay? Now, okay, this is the one that I was showing earlier, but you don't need to know that. Okay, so instead of typing, I just type in fluoxetine, caffeine, and example. Okay, this is just to recall previous output. We talked about this already. One equality, and plot the sine wave. It's going to make suggestion. Blah blah blah. So this is about the language itself, and then okay. This is an example of using Wolfram Alpha, right? Equal solar eclipse. Look at that. And then I have this link called, Wolfram plugin and all kind of stuff. Okay, now this is where we should start thinking about software ecosystem. Again, you start this application, it's a software, it uses a language, now we call it Wolfram. Wolfram is a language for Mathematica. Okay, now let's think of the ecosystem. One of the most important component of an ecosystem is the data set, or some sort of like a data repository. Okay, this is where for those of you who are into data science, and some of you took data analytics class, we had some project, you would probably go to GitHub, Keiko, and all kind of stuff, right? But this, I'm talking about what's called example data. So these are internally curated data. And even though it's used for demonstration purpose, chances are it's so big, you can learn, chemistry 101, 102, 103 from this alone. right? So example data, let's see what we got. It's got so many kind of, yeah. Again, example data is a function. It doesn't, you haven't put any argument, but it's a function. Again, Mathematica is functional programming. You communicate with it by either defining what a function is or calling a function. Okay? In fact, everything you do comes down to that. When you say A is equal to 5, you're not making a statement. You're calling a function that assigns the value 5 to the symbol A. So everything you have to think of as a function. Okay? So again, if I say something like A equal to 5, it's an assignment. So everything is a function. Likewise, this is a function. A function say example data. Give me what you got. Well, you haven't supplied anything, so it gives you suggestion. What do you want? Arrow, image, audio, color, texture, data set, geometry. So let's say I want to play with, so these are all sort of like built-in, okay? So statistic is what I use for the class. So I have that a lot, okay? So obviously I type in statistics, okay? Now, I happen to add this thing called length, but never mind. This is it, okay? How many statistic data set? In here, already clean, okay? You don't have to download, you don't have to mix the 0 and 1 and the null and all that. So many things, a whole bunch of things. So these are example statistics. Now, if I have this, okay, you will notice that a list of things is always put in a curly bracket. So it's a set, there's a curly bracket outside that has all these items. All these items has the beginning item as statistics and the other one as more specific. So basically this is a kind of like archiving, right? So you say, okay, all the example data that you can play with are put into different groups. One group is called statistics group. So these are mostly numerical data, okay? So there's some image data, but I'm gonna play with numerical data. And these are the one that I have. I don't know, Australia rainfall. These are all example. Camel heat, I don't know, cement heat, I don't know, all kind of stuff, okay? Now, if I put something like aerial image, I get something else. Okay, San Diego, God knows, Earth, and all kind of stuff. Color, texture, okay. So these are example of built-in, okay, built-in things you can play around with. Okay. Now, I can do this. Let's say I have example data right now, right? That has a whole bunch of things. So if I do type in example, open bracket, the argument is not a number, but it's actually a text called statistics. So type this in. Okay. Now put a bracket around it. Put a bracket around it. Okay. And in front of this, type the word length. So what it's going to do is, because example data is a list of items, right? When you give you the length, that's going to give you just how many there are. So now I know how many there are. Okay. Now, earlier you saw me using this kind of shortcut. Sometimes it's convenient to say, take example statistics and give me length. Okay. Sometimes you will see the opposite. Instead of saying length of this, again, 111, I would say length apply to this. Okay. Why do I do this? Because sometimes you have so many functions. You have something like, f of g of h of I of k of x. Okay, and then you have 1, 2, 3, 4 bracket. That looks a little bit clumsy. Okay, so sometimes for unique when there's only one argument, you can just use add. And then you don't have to worry about the back. Now, this thing you don't have to pay attention because it's a shortcut. For those of you who use all the time, these are helpful keystroke saver. Okay. Anyway, so this is another example of a function. This function called random sample. Again, it's all black because it's built in. This random sample, just say, give me a list. I'm just going to pick a few. How many? Well, let's pick 20. Okay. Now, notice it picks chemical, process, temperature, Fisher iris, Crab measure. Okay. If I shift enter again, it's going to come up with another one because it's random. Okay. Oops. Not giving a different random. This is kind of weird. Maybe I said something. My apologies. Just ignore what I did. Okay, but it should be fairly random. Okay, yeah, let's do that. Okay, so every time I put shift enter, it's gonna come up with a different random. Okay. Now, so okay, one thing, and you don't need to know the detail, is that what you can do is take it all the way to prototyping. Okay, so let's say you guys like to make this prototyping an app, right? It's the same kind of thing, right? In this case, by the way, this is a link for interactive working for the. So what I did was I create something. I create this. Okay. This is it's a silly little function. I ask for click for red, and it just kind of gives you a random picture of red or random picture of green. Okay. So this is to help your friend or your sister choose. So today is Wednesday. She wants to wear green. So which green should she wear? You know, you can use this function to help. So let's say this is an app, right? You want to showcase this, but you don't want to carry this thing around. So what you do is you can do cloud deploy. Okay, cloud deploy. So when you do this kind of cloud deploy function, yeah, so you this cloud deploy now. Cloud deploy. So so I make this thing, and I use the recall. So I cloud deploy this thing, and I give the public permission. Now, this is going to, for the first time you use it, you won't be able to do this. You have to have like an account, I think, to do cloud deploy. But I already have an account, so it automatically, oh, it doesn't. Okay, I'm not on this machine. I haven't logged in. Okay, I don't know. I don't remember my password. But let's see if the previous one is still around. Oh, no. Okay, anyway, what happened is that this thing, instead of being in the program, it's going to be accessed to URL. Okay? And that URL, you should be able to access. Okay, so you have data, which is internal. You have functionality. Once you make the functionality, you can export it to the world. In fact, this is how, when let's say I want to pitch an idea to my client, I don't necessarily want to carry my laptop. I can say, okay, I'll just send you the link to this and you can play with it. Okay, now the person doesn't have Mathematica, so must use this access from the third party. Anyway, right, enough about ecosystem. So the idea here is, well, the history of it is it's used for theoretical mathematics. Okay, let me show you what I mean by that, and in case you don't understand. Okay, this is what Mathematica originally was designed to do. Okay, something like, okay, mathematical calculation. So let's say integrate, okay, x, oops, integrate x to the power, I don't know, 7, 6 log logarithm or something, something like x, right? So you want to do something like logarithm of x to the power 6 dx from 1 to 7.5 something. Okay, this is what it's meant to do, the kind of like computational work. Okay, computational work. But it evolved into a more general high-level language anyway. So right, so to work with it, you need to know some primitive. That's what this means. Primitive, the most simple thing is assignment. When you say x is equal to 1, you notice that x is blue. X is blue. When you say x is equal to 1, now x is black, right? So every time you say x, it's now 1. Okay, now you can clear this. So clear x, and now you don't know what x is. Okay, the way Mathematica say it doesn't know what x is to do that. Right. Now let's look at some fun thing. Now this is where this is beyond your thing. But let's say one of the technology you want to work with is has to do with thermodynamics. Okay, could be from engineering or whatever. Okay, so you might be making a nanotechnology innovation. You have to parameterize something, use differential equation. Okay, well, this is what differential equation looks like. Raise your hand if you haven't done calculus, if you have not. Okay, so you know what this is, right? So I call this function u of x of t. U is a heat function. Okay, I just define it. Okay, u is a function, heat function. It's a function of x, it's a position, t is a function of time. So if I have something that's hot, as a function of time, it dissipates heat. If I have something that's hot, I go near it, it's hot. I go further out, it's not so hot. So it's position. So position and time. Now the heat equation is the first partial derivative with respect to t is equal to second partial derivative with respect to h. So that's what this function looks like. Okay. Now, once I've done this, I can define the UH later and I can do calculation, all kind of stuff. Now, the most basic thing is a variable x. X is one thing. But in computer, you never deal with one thing because the whole point of computer is you can do one thing to many things at once, right? So you tend to work with lists. So what if my list is ABC? So this is it. This is ABC. So this list, because Mathematica, unlike other language, is more general, it allows you to do anything. So that is a list of number 12, the word blue, and the word both. The difference is the word both is a purely string. The word blue is a function. So when I got this, is that has 3 items. How do you access individual item? I put down that. Okay. 3 items. I want the first one. I put double bracket. I want the second one. I want the third one. I want the fourth one. It doesn't. I want the first one from the back. I want the second one from the back. I want the second one from the beginning. Third one from the beginning, from the back. I want all of things the same thing. Okay. Now, so beyond this is as simple as it gets. So basically, this is a way you name things. Okay. Double bracket gets you individual item. Now, what if you have 3 items and you want the first to the second? What you do is the first one, dot, dot, dot to the second. That would be what you think. But Mathematica use semicolon twice. Okay. So this is the same 1 dot, dot, dot 2. That's all you have to remember. Okay. So once you memorize just that, a function has a bracket, a naming is equality, a list has curly bracket, accessing individual item works like this, then you can start playing with a whole bunch of stuff. Okay. So now let's go to the function. Some function has absolutely no argument. Okay. Because now you don't even have to put in the bracket. It knows. But most of the functions are not like this. Most of the function expect something. But now it's one of those functions where now is now. Okay. So right now it's 15, 40, 51. I put now again, it's 4105. Now again, okay. Tomorrow, okay. Tomorrow doesn't have a time because tomorrow is just a date. So I would call this just a prompt. Now, command is like a function like this. It's a function with no argument, but basically it's similar. Okay. This function happens to be the one that say, where is his notebook, blah, blah, blah. Now we start to have mathematics. Okay. Mathematics is never a function of no argument. It's a function of x, or x1 and x2, or x1, x2, x3, x4, x5 to x100. Exponential function, what's that? So exponential function, that's that. Right? Exponential of, okay. Now, what's the log of exponential? Gets back to the same thing, right? Okay, fine. No surprise there. Okay. No surprise there. Now, this is not very elegant because exponential, and for those of you who want elegant, just remember this, but for those of you who don't care, escape E. Now, there are many E. There are many E here. Go to this guy. Exponential E. Okay. Shift enter. Shift hat. Oops. Control hat. I don't know what Mac is, but for Microsoft, it's control hat, and that gives you something like this: 12.34. Okay, so it's more elegant. Now, is it the same thing as to check whether it's equal? You tap double equal, exponential, 1, 2, 3, 4. True. Okay. Likewise, you can try something else. Is remember pi, S-P-I, pi, is it equal to 22? Now, I can use control divide. Oops, sorry. Control divide and put 7. Okay. Is it equal? False. Okay. It's close enough. It's close enough, but it's not exactly. Okay. Dimensions. So all kind of stuff. Now, this is where things get a little bit hairy. When you do some technology, particularly computer algorithm, uses a lot of discrete mathematics. And Mathematica is very powerful. For example, you can factor integer. You know what it does? It says that this big number is 2 to the power 3 times 41 to the power 1 times 89 to the power 1. See if that's true. So it's very powerful. Okay. Or maybe you can do factorial. Have you guys ever done factorial? Like 7 factorial? Okay. So it's very powerful. So now, This is the integration in mathematics. This is integration in a function form. So I'm going to skip a lot of this. Matrix, table form. This is all, making things look nice. So basically, now, this is kind of fun. This is saying h of g of f of x, is it equal to h applied to g of f of x? Is it the same thing as x and then f and then g and h? Turns out these are all the same. Okay, now don't have to worry about this. This is only useful if you program a lot and sometimes you want to save on keystroke. Most, when you're learning, you just use this form. So I'm gonna skip all this. I'm gonna skip all this. I'm gonna skip all this. Right. There's a little function that rotates the text, so I'm going to skip all that. These are all little functions. For those of you who know linear algebra, and you should know linear algebra, you should know that a list can be used to represent a vector. So a dot product can apply. So if you have AB, yeah, let's do this. AB dot, literally dot, CD, what do you think you're going to get? It's going to be AC plus BD, right? So this is linear algebra. So you can do all kinds of linear algebra stuff. I'm going to skip all this. This is differentiation, right? So you can take differentiation with respect to x to y. You can take. Now, this is something, by the way, as simple as it looks right now. You can't do this in Python. Python is not an analytical engine. So you can do numerical differentiation. You can't do symbolic. Like x to the 7. What's the differentiation of x to the 7? That's 7x to the 6. Python can't do that because it doesn't understand symbolic differentiation. Okay, but here you can, all kind of stuff, right? So I define some function, maybe, right? All kind of stuff. So for example, here, you guys know what this is? This is x to the power 3, y to the power 3, differentiate with respect to x 3 times. So that's 6y to the 5, to the 5th, right? Now, so this is basically the text depiction of the function. So it does this. None of this can be done on general language like Python or R because it doesn't understand differentiation, but this thing does, okay? It does also do integration, okay? Blah, 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 blah. Now, let's get to the interesting thing. Okay. Right. This thing, I put it under. So you need to know a few things, okay? You need to know what a list is. Now, list can be defined like this, right? Say something like, just now, let's say x, what was I saying before? A y, okay, y is equal to 1a, b, c, right? And then I can do something like y1, okay? But what if I don't want to define manually? I want the list to be something like a number from 7 to 5,000. Okay. In that case, I use constructor. Would be something like range or table. Table is the most usual form, the most ubiquitous way. Okay. What you do is something like this. Table I. Okay. Let's see what happened. Let's do this. What do you think this function does? This say table of I to 5. What do you think that means? Well, is a shorthand because I has to go from something to 5. But common sense say, hey, if you don't put anything down, might as well assume that it starts from 1. Again, Mathematica is trying to save you keystroke. The only thing Mathematica is not friendly is bracket. Bracket, you have to put all of them yourself. But sometimes something like this makes sense. Table of I from 1 to 5. Okay? Right? And then you can do something like, well, what if I don't want to start from 1? I want to start from 2 to 5. Okay, fine, then say so. What if I want to 2 to 10, 2 to 15? What if I want to do 2 to 15 instead of 3.1? So 2 plus 3.1 plus another 3.1 plus another 3.1 plus another 3.1 until it exceeds 5. So type this. If you type this, you're going to be familiar with understanding. Okay, again. So table. So definitely Mathematica, you need to know x is equal to 1. You need to go x is equal to 1, 2, 3. You need to know x is equal to table I from, I don't know, 2.1 to 7.8 instead of 3.4. Okay, if you know the meaning of this, and this is one of the easiest thing I can test, right? So now you know how to handle stuff. So this is one thing, this is a list of things enumerated by hand. This is a list of things enumerated by symbol. Now, what if I, instead of doing this, I say something like A, control, hat, I. What do you think is going to happen? It's going to make A to the 2, A to the, it's going to make this, right? So this is all symbolic. Until I specify what A is, it's going to give you this. Okay. Now, if I give A a value, I don't know, 2.2. Now I get numbers. Okay. But if I didn't give it a number, I give it hello. It's going to say hello to the power 2. So this is just a name. Range is kind of like a shorthand for table. I don't know. Table. So table is used a lot. Table is used a lot. Array, not so much. I'm going to skip that. So you need to know table. So now, so table x is equal to, now, so x, I doesn't have to be, you could use something like exponential I, for example, right? Okay, so this thing you have to know. Fine. Association, maybe I'll teach you, maybe I won't. In the interest of time, I won't. Now, what I want to get to ultimately is 2 things. Okay. What? Okay. Define a function. Okay, and it's down here somewhere, so I'm going to start fresh. Now, this is function definition. I want you to know my function. Notice it's all blue, right? Because it's not built in. I put in variable a underscore. Now, underscore is very important here because it say use this to match whatever comes in the future. So it doesn't have to be a. This is like a placeholder. So let's say my a, b equal, but because it's a function, I'm going to put semicolon equal. Okay. And I'm just going to define it the way I like. Let's say log of a plus b. Okay. I'm just going to define this. Watch this. This is slanted because it's a variable. It's in green. It's slanted. It's in green. So this, the computer doesn't know it's in blue. I'm going to shift enter. Once I shift enter, this becomes black. So now if I say something like, okay, my function, okay, cat and dog, what do you think is going to happen? It's going to return log of cat plus dog. Okay. Now, unfortunately, cat and dog doesn't mean anything. So what if I put 1.7 and then 2.4? Okay, then it gives a number. Okay. So this is called, so you know how to do this. This is called using a function. Okay. Now, one more thing that I'm going to show you. Okay. Why it's useful, and I'll come back to this when we actually have a program. When you go into those demonstration program, you will see a lot of manipulate. You will see another thing called module. What a module does is this. Normally, when I say x is equal to 1, x is equal to 1 forever, right? I have to actually clear x to free it up again. Now, what if I want to do this? Okay. My function number 2, okay, watch this. I want to do this, but I want to do something more complicated. Okay, so let's say this is something complicated. I can do module, M-O-L-E. Okay. That module has 2 parts. The first part is a local variable. Let's say my local variable is called sum. Put it in a bracket because I can have more than 1, comma. Okay, and then I can do something like sum equal to A plus B. Semicolon, I can do all kind of stuff. And then I can do this. Okay. Now, that's the same thing. Let's call this function 2. My function number 2. Okay. This function number 2, that's exactly the same thing as before. Cat, dog. Right? What's the difference? When something's simple, you just do it right away. When something is complicated, sometimes you have to have interim variable. And in order to have something that you use once or use here and not use it again, you put inside the module. Okay? And now, when I say sum, I just say sum. It doesn't know what it is. Because outside the module, nobody knows what the sum is. I don't have to clear it. Okay? So, this is a second thing I want you to know. Finally, putting it all together. Okay, putting it all together. Remember that thing I have this manipulate. Okay, so what if I do this? What if I say, yeah, let's do this. Now I put module and function together. Now I'm going to put module and manipulate. So let's say manipulate. Okay. Now we did this before, right? Plot AX, right? Plot AX, X from minus pi to comma pi. Okay. By the way, if you don't want to be fancy, you can use pi because this is fairly universal as well. Pi. Okay. Plot this, and then I want to manipulate a. Let's say from what was it? 1 to 10 in step of 2. Okay. Oh, sign. Okay. Now, this is simple. So I'm going to put it here. Right. Now, Next thing, I'm just going to put module right here. Module. And I use product. And then comma. Product equal to A and X. And then plot product. Oh, sorry. Yeah. Now, it does the same thing as before, so don't be excited. Except, I could have something more complicated because I have an interim variable. If you remember just what all this means, this is a very shortcut way of doing things. Okay? These are all the constructs you need to know. Okay? So, assign a variable. This is a list. This is a table. It's a fancy way of creating a list from symbol. This is a way of defining a function, function 1. This is a way of defining a function with complicated intermediate step. This is a way of manipulating a plot. This is a way of manipulating a plot with some complicated step in between. Okay? So these are the keywords: table, module, manipulate, plot. Just about variation of all of this is all you need to learn anything. Okay, now there's going to be plot 3D, there's going to be vector plot, there's going to be plot this, plot that, plot this, plot that. There's going to be, right now you saw molecule plot, right? So it's a very fancy way of plotting, but it will operate on the same principle. So if you understand this kind of like, let's call this save as all the basic memes in Mathematica, you need to remember. Okay, I'll just call it that. Okay, I'll just call it that. Save. Okay, and here I can give this to you later. And okay, we kind of run out of time, so I'm not. I'll do it later, and I'll send you a whole bunch of things. Okay, so you should have something like this, like unentitled for, except you should save it as. Save as what? Save as. Okay, watch. H W K 3 slash and then your student ID. Okay, and then submit it. Homework 3 slash and student ID .nb and turn it to my course view by 1410. Okay, so next week I will give you something to play with along this Mathematica revision kind of thing. We won't have a class. I'll work on makeup. Now, for those of you who really likes to learn more, I can certainly share you this thing, notebook. But again, this is not learning Mathematica class. This is not learning data analytics. This is using the basic plotting, visualization, manipulation, function definition in Mathematica to learn about technologies. Your homework, okay, and I'll let you do this. Your homework, again, homework number 4 is, oh, okay. I signed in already. So let's say, was it autumn, spring, EmergingTech. Okay. Okay, homework 4 is to go to Mathematica demonstration and pick your demonstration project of choice. Download .nb, study it, and report what you learned. Okay, now watch. Look here. When I say report what you learn, I'm not concerned so much with learning the Mathematica syntax, right? Because after all, you know, if you want to extend, you have to understand the Mathematica code so you can keep programming and add to it. Right now, no. Right now, as if you don't know anything, you just want to play with the variable. Okay, so imagine that you don't have Mathematica, you only have this play version only. What have you learned about this? So what did you learn about, what was it? Deutsch algorithm in quantum computing. How does different variable change the outcome of the analysis? How does addition of different molecule type do something? I don't know. Okay. Now that's part 1. Sorry, let's make it homework 4B. 4B is to tell me sort of what you want to do, want to study in detail. Okay, so for example, let's say one of you say biodegradable plastic. Okay, so any kind of emerging topic, emerging technology topic. Okay, so submit it as part of this homework. So this homework should be written in Word, I guess. Yeah, Word. Okay, so homework 4 dash boop 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 dot docx. A, what you learn from demo project. B, what emerging tech area you like to dig deep. Okay. Now this homework 4 is not due until later. I'll give you actually 2 weeks.